Today we're going to be talking about simplifying roots that also contain variables. The first thing I want you to keep in mind is that x squared is the same thing as x times x. X to the third is the same thing as x times x times x, right? If I was going to say x to the 10th, how many x's would that be? Well, it would be 10. 4, 5, 6, 7, 8, 9, 10, right? So let's try simplifying a couple of these. We're going to start with the fairly straightforward ones. If we remember our invisible math, there is a 2 here. And so when we are trying to simplify a radical, we are looking for pairs. I see a pair of x's. When they exit the house, there will be only one of them. So the square root of x squared is simply x. What if I have 3 x's in there? How many pairs do I see? X times x times x. I see one pair of x's. So the square root of x cubed is x on the square root of x. What about if I've got 4 in there? I see one pair of x's here. I see a pair of x's here. And so I have x times x on the outside. Nothing's left on the inside. And x times x, well, if we go back and we remember that x squared is x times x, that simplifies to x squared. Is there a way that I could check this using Desmos? Well, it wouldn't be Miss B if I didn't show you a way to use Desmos to check this. So you can check that what you've simplified is the same as what you started with if you use sliders on Desmos. You don't want to use X or Y or E. Those are defined in Desmos. So I always give you guys the hint to use your initials. I'm going to use B for Miss B. So if I want to look at the square root, I type in SQRT of b to the 4th and add a slider. Choose anything other than 1. I'm going to set it to maybe 4. And I want to see that b squared is the same thing. I can tell that these are the same. And so we've simplified that correctly. And I've saved this. I'm going to share it with you guys in the notes. So let's try a couple harder ones. M squared is the same thing as m times m. N cubed is the same thing as n times n times n. There's an invisible 2 here, so I'm looking for pairs. I see a pair of m's. I see a pair of n's. On the outside, I have m, n. And on the inside, I have an n. And this is the simplified form of this. Let's check it in Desmos. So we've typed in what we started with. We typed in what we found it to be simplified at. We're going to add sliders to all and set those sliders to anything other than 1. How about 2 and 3? And when you do that, these should equal the same number, and they do. So we've simplified it correctly. What if we have one that also has a coefficient? Well, we can go back to our birthday cake for the number. And if we want to remember our prime numbers first, 2, 3, 5, 7, 11, 13 is good to start with. We're going to put 8 in the cake. Pick any prime number. I'm going to pick 2. 8 divided by 2 is 4. 4 divided by 2 is 2. I don't know why that happens. And 2 divided by 2 is 1. Our factors are on the left-hand side, and we can put those back in the house. We have 2 times 2 times 2, and x squared is x times x. We're looking for pairs. I see one pair of 2's. I see one pair of x's. On the outside, 2x. On the inside, the square root of 2. And let's double check that with Desmos. So we want to choose something other than, well, let me take that off. It was 2c on the square root of 2. I've chosen c as the variable here because we can't choose x, so I'm going to add a slider, maybe set it equal to 5, and these should match. Oh no, they don't. I found my error. We started with c squared, and they do match. We had 8x squared, and we found the simplified root to be 2x on the square root of 2, and sure enough, they do match. So we'll try one more. This will be the last one I do. We're going to start by simplifying the square root of 27. We're going to find the prime factors, excuse me. So I'm going to start with 3. 27 divided by 3 is 9. Divided by 3 is 3. Divided by 3 is 1. And over here on the left-hand side, these are my prime factors of 27. I have a square root of 3 times 3 times 3. Now I'm going to move over to this x times x times x times x, and then I'm going to move over to this y times y times y, 2 y's. I'm looking for pairs because there is an invisible 2 here that I cannot see. I have a pair of 3's. I have a pair of x's. And I have a pair of y's. On the outside, I have 3xy. On the inside, I have 3x. And this simplifies to this. I'm going to check it in Desmos real quick. I can't use x and y, so I've used g and h instead. I'm going to add sliders to all. I'm going to set them at numbers other than 1. And you can see here that they match. So we have simplified that correctly. Thanks for watching. I hope this was helpful.